Ciao a tutti.
Hi everybody. Today we're going to see what happens to us when we wear a face mask. All face masks have the same purpose, that is filtering the incoming or outgoing air, or in both directions. Obviously, filtering may differ very much depending on the type of mask we are wearing. These are, for example, masks that I bought at the stationers for my children. They are simply cloth masks made of cotton to which one can apply a filter. I found this mask in the mailbox, a donation received from our municipality, or professional masks that have a more technical filter, and obviously also the filtering capacity is quite different. A simple cloth used to cover one's nose and mouth. Actually, all these types of protection create a barrier to breathing, and this caused problems that we are going to see now.
Adesso andiamo a vedere. Tutte le nostre cellule.
All our cells continuously need oxygen, and they use it as a comburent to oxidize the nutrients that come from the food, which is our fuel.
In altre parole, noi mangiamo del carbonio.
In other words, we eat carbon with lower oxidation state, for example, a good sandwich, and we burn it thanks to the oxygen that comes from our breathing. This combustion occurs through many numerous exothermic reactions of oxidation reduction. These reactions release energy, and in particular, a molecule called ATP, that is the energy molecule of our cells. All this complex process, however, releases a molecule that is carbon dioxide. At the end of the process, carbon dioxide is eliminated through exhalation. The constant and very precise control of both oxygen and carbon dioxide concentration in our blood is fundamental for our survival. There are specific nuclei made for this purpose. We can find them at the level of the brainstem, which is part of the central nervous system. This nuclei structure also collect information from more distant areas, such as the aortic arch, where there are receptors that constantly measure the concentration of oxygen and carbon dioxide in the arterial blood, and send this information through dedicated sensory nerves to the nuclei of the brainstem. This information is processed and used to calibrate respiratory volumes and respiratory rate. Then these nuclei send out more motor signals to the inspiratory muscles, for example, the external intercostal muscles or the diaphragm, which is the main inspiratory muscle we have.
È il principale muscolo inspiratorio che abbiamo. Andiamo ad analizzare cosa succede ad una persona.
Now let's go and see what happens to a healthy person if we alter the ventilation system by increasing resistance. For example, when using a mask that filters the air, but at the same time also hinders the passage of air, both while breathing in and out. This situation is well described in literature. In fact, the increase in ventilation resistance was used as a strategy to stimulate altitude training. I remember when I taught sports science at the university a few years ago, there was a lot of talking about this, because it seemed that it could be a very promising strategy. Basically, the idea aimed at solving the following problem.
Un problema che è questo. Come poter allenare, ad esempio, un atleta?
How to train, for example, an endurance athlete who lives in a town at sea level, for example, Trieste, just if he were training at high altitude, in the mountains, for instance. Altitude training has a significant advantage because there is a less atmospheric pressure, which causes a greater production of erythropoietin, EPO, a hormone that increases the number of red blood cells, and this gives the very well-known and much wanted aerobic advantage. So the issue is how to train someone who lives at sea level as if he were training in the mountains.
Se ci allenassimo in montagna. Ovviamente non si può cambiare la pressione atmosferica.
Obviously, the atmospheric pressure cannot be changed, but one can wear a mask with valves that regulate the resistance of the air inlets and outlets. Let me tell you right away that these masks do not give the produced desire. They do not increase the EPO. However, other things happen that can be of interest to us today. They are well described in various scientific papers, like, for example, effect of wearing the elevation training mask on aerobic capacity, lung function, hematological variables. Obviously, the authors described everything very well. What the athlete does, what kind of training is carried out, and so on. In my opinion, for our purpose, reading it now, it's quite boring, so I will give you a summary of it.
Innanzitutto, gli autori sottolineano.
First of all, the authors underline the fact that these masks do not give the desired effect, which is the increase of EPO in the blood. As a matter of fact, these masks cannot be used rationally to simulate altitude training. The authors add that there is some extra work in some specific muscle groups. For example, the inspiratory and expiratory muscles. And this is quite obvious. I put a resistance to the ventilatory flow. The resistance will be overcome by more mechanical work done by the muscles which expand the rib cage, that are the inspiratory muscles, and then by the muscles which reduce the thoracic diameter, which is the expiratory muscles. There are scalene muscles, intercostal muscles, diaphragm. All these muscles have to do more mechanical work. Furthermore, the authors indicate quite a few signs and symptoms that emerge when the training is very intense. Hypercapnia, an increase of the concentration of carbon dioxide in the blood. And this is also a parameter that one can expect when one has a mask on. In inhaled air that goes down to the lungs will not be fresh, clean air. It will be a little bit contaminated by the previous exhalation. So it will have a lower oxygen concentration and a higher carbon dioxide concentration, and this will not facilitate the exchange between blood and air, causing hypercapnia, an increase in the concentration of carbon dioxide in the blood.
Ipercapnia, perciò un aumento della concentrazione di anidride carbonica nel sangue. Aumento della frequenza cardiaca, anche questo.
An increase in heart rate. This is also a fairly logical parameter, in as much as one has to use more respiratory muscle. Hyperventilation, the number of ventilatory acts, and also the volume is a little greater compared with the same activity done without a mask. Dyspnea, shortness of breath. If I have a seal over the nose and mouth, obviously this is also a symptom of dyspnea, is perfectly consistent. Increased blood pressure, muscle spasms, fatigue, central temperature increase. That is another logical parameter of alteration. When we exhale, when the air goes out, we don't just throw out carbon dioxide as it is. The temperature of gas that we throw out is higher than the temperature of inhaled gas. Therefore, breathing during physical activity, especially during expiration, is an instrument for dissipating heat. The masks do not help this process.
Perciò un leggero aumento della temperatura centrale. Propensione ad avere aritmie.
Propensity to arrhythmia. People who are aware of heart problems must be very careful and should avoid this kind of masks during training. Disorientation, sense of unreality and panic crisis.
Non bisogna mai fidarsi di ciò che si legge.
I think we should never trust completely what we read, even if it is scientific literature, and we should always try to test everything we can through our own experience. For this reason, I asked Fabio to run with various masks so that he can make an assessment ourselves. Let's see what Fabio did.
Cosa ci racconta Fabio?
Io in questi giorni ho avuto modo di provare vari dispositivi.
These days, I have had the opportunity to test various protective devices during the run, and now I will tell you what my feelings are. So, I first tried a scarf with no problem apart from a slight sensation of discomfort on the skin. Then I tried a very light mask without filter, which also provoked some discomfort to the skin. Certainly, I felt that the air could not pass through easily. And a queer sense of breathing should also be mentioned. Then I tried a mask with a real filter. It gave me a huge discomfort to my skin. There was also high humidity that was felt even during the inspiration, mostly when I increased the pace running, and in particular while going uphill. I also felt a sense of dyspnea and palpitations. In conclusion, I would say that motor activity and masks do not get along very well. Unless one wants to strengthen the respiratory muscles, all the other parameters are clearly negative. It is not convenient to practice motor activity wearing a mask. I am aware that there is a problem spreading the virus, but the issue should be addressed in another way. If a person wants to practice motor activity, especially if he wants to do it intensely, he has to be in an isolated place. Furthermore, to emphasize this aspect, I must say I didn't find any bibliographical reference in scientific literature that highlights the real ability of masks to provide protection from viral infection during motor activity. Indeed, it is rather emphasized the contrary, that a mask tends to lose its effectiveness when it becomes wet. I think it is quite simple to understand that during exercise, especially if it is intense, a mask does become a little wet. That's all for me. And thank you everybody.
Finirei così e grazie a tutti.